We're going to talk briefly about tests of independence and tests of homogeneity. Each one of these uses contingency tables filled with columns that have the same variable in them and rows with the same variable. So here we have a test of independence, and what we're looking at is developing the flu dependent or independent of treatment. So we actually are going to look at the hypothesis, or the null hypothesis, which is getting the flu is independent of the treatment, and the alternative, which is that those two things are dependent. Contingency tables are always right-tailed, so that's something to keep in mind when we're talking about significance level and critical values. To find the critical value here for our table, we're going to use a chi-square table. Because it's right-tailed, we're going to use our entire significance level 0.05 in the right tail, and then our degrees of freedom are calculated by taking the number of rows and subtracting 1 and multiplying that by the number of columns and subtracting 1. So we have 2 rows minus 1 times 2 columns minus 1. That gives us 1 times 1 is 1. So we have 1 degree of freedom that we're going to look up in our table. So first row of our table. When we look down that fourth column and look in the first row, we see that our critical value is 3.841. And what we want to do is compare that the test statistic that we're about to generate to that critical value. So let's do that. We'll show you how to use StatCrunch. We're going to open StatCrunch. And we'll go to Stat, Tables, Contingency, and then when it's filled with just counts like that, it's summary data. So we're going to grab that. Our columns are developing the flu and not developing the flu. The row labels, treatment versus placebo, that's in column that's labeled variable 1. So we'll select the titles for our row variables and hit next. We could do expected count to kind of, under the null hypothesis, see what the expected counts should be. And this confidence level here has to match our significance level. So because we have a 0.05 significance level, that's a 0.95% confidence level. And we'll hit calculate. Here are the results. So we'll take a look at those and interpret them. Again, it just puts the expected counts. If the null hypothesis were correct, these are the expected counts that we'd see. Down here, it tells us the test statistic and its p-value. If we compare that to our critical value, we can see that this test statistic is less than the critical value, which means it's not going to be more extreme or in a critical region. So our conclusion would be that we fail to reject the null hypothesis. So it looks like developing the flu is independent of the treatment. What that suggests is that that vaccine is not very effective. If those two are not related to one another, it means this vaccine is really having no impact at all on whether or not you develop the flu. They're independent. So we're going to choose over here, does the vaccine appear to be effective? No, because the test statistic is less than the critical value. If we're interested in looking at this from a p-value perspective, this p-value right here that came up in our analysis is 0.139. That is larger than our significance level, and so we would fail to reject the null hypothesis, which is consistent with our traditional method of looking at it. But that's something to keep in mind. You can actually look at that p-value right here and compare that to the significance level. If it's less than the significance level, then you would reject. If it's greater, you fail to reject. Okay, here's a problem where we're going to talk about the proportion being the same between one group and another. So this is a test for homogeneity. So what we're asking is, are the proportions different between these male and female interviewers? And a homogeneity test is calculated the same way as the test for independence using a contingency table. But let's take a look at our null versus our alternative hypotheses. The null is that the proportion of men and women who agree are the same regardless of the sex of the interviewer. The alternative would be that they have different proportions. Contingency table tests are always right-tailed, so to find the critical value, we're going to pay attention to the significance level right up here. We have 0.10 in the right tail, so if we look on our chi-squared table, that would be the 6th column, and then the degree of freedom is calculated the same way. We have 1 because it's a 2 by 2 table, and so the critical value is going to be 2.706. So now we're going to go grab the test statistic out of StatCrunch. So we'll open our data into StatCrunch. We'll get our contingency table with our summary data. Those are the columns for the table, and the row labels are in variable 1. We'll do expected count. And then something to pay attention to here is the significance level. Remember, we have a 0.10 significance level, so that means here we need to change our confidence level to 0.90. And then we'll calculate. Okay, well, our test statistic here is 58.36013. So our test statistic is, we'll type this in here, 58.360. Well, our conclusion is, since the test statistic is so much larger, we're going to reject the null hypothesis. It falls in a critical region. So that means that these two proportions do not appear to be similar, which means the interviewer may have some sort of influence on the respondents. This checks out with the p-value method. If you look at the p-value, it's very, very small, right? Less than 0.0001, which is much, much smaller than our significance level. And so based on the p-value method, we would also reject the null. Those two methods should be consistent. We can see that they are. Okay, so we would say, does it appear that the gender of the interviewer affected the responses? Yes, because we rejected the homogeneity. Okay, hope that helps.